Determine if the series is convergent. If it converges, find its sum. This is a partial fraction decomposition setup where we have 6 over 4n minus 1 times 4n plus 3. And we have to figure out what that is over 4n minus 1 plus something else over 4n plus 3. So A needs to be multiplied by 4n plus 3. B needs to be multiplied by 4n minus 1. And the n is supposed to equal to a 6. N can be equal to anything you want it to be. If we first choose n to be a fourth, we have 6 is equal to A times 4. So A is 3/2. And then if we let n equal negative 3/4, we'll have 6 is equal to B times a negative 4, or that B is negative 3/2. So it breaks apart to be 3/2 over 4n minus 1 plus a negative 3/2 over 4n plus 3. It'll help if you factor out the 3/2 and have it as 1 over 4n minus 1 minus 1 over 4n plus 3. Let's do that. Let's take the 3/2 all the way out. 1 over 4n minus 1 minus 1 over 4n plus 3. Alright, n is 1. What do we get? Don't worry about this 3/2. Just remember it's there. When n is 1, we get a third minus a seventh. When n is 2, we get a seventh minus an 11th. When n is 3, we get an 11th minus 15th. You see the pattern that the denominator from one part to the next going up by 4. N is 4, we get a 15th minus a 19th, and so on. At the end, we're going to get 4n minus 1, 4n plus 3. The one before that is going to be, what's that going to be? How does this cancel? We cancel the 1/7, the 1/7, the 1/11, the 1/11, the 1/15, the 1/15. So this has to be a 4n minus 1 to cancel with this one. And then what do? We take away 4. So maybe 4n minus 5 here. And it would have canceled with the one that was right before that. This 1/19th, everything in the middle collapses. We're left with surviving. When we go to look at the partial sum, S sub n, we get 1/3 minus 1 over 4n plus 3. The limit as n goes to infinity on Sn is 1/3. That's not the sum though. Remember we had that 3/2 out there? The sum is 3/2 times that 1/3. So the sum is a half. Telescoping zeros.